Alright, so good day everyone. Today's sessions we're going to discuss about the random variables and the probability distributions. So our goal in this topic is we're going to describe the random variables and the probability distribution. Second is we're going to determine the possible values of the random variables. And the third one is we're going to construct a probability distribution, particularly in a discrete random variables. So let's start with the random variables. So how can we describe a random variables? So when we say a random variables, it is usually written using a capital letter. It is a variable that assigns a numerical value to each outcome of a random event. So a variable class can be a random variable if these variables can be determined or can be randomly selected on the particular event or particular experiment. Random variables, it pertains to the numerical outcome or the numerical output of a random event, which represent as using the capital letter in the English alphabet. So in our random variable class, we have two types of random variables. The first one is the discrete random variable. So and the second one is the continuous random variable. So when we say discrete random variable, it is one that can assume only a countable number of values. It is a random variable whose possible values for a finite or a countable set of numbers. So a discrete random variable is a kind of random variable can be countable. The examples of random variable or discrete random variable is number of pencils in the box. Second is the number of soldiers in the troop. Number of rotten tomatoes in the basket. So these variables can be accountable. So it can be classified into discrete random variable. Another type of random variables is the continuous random variable. It can assume infinite number of values in one or more interval. It is generated from an experiment in which things are counted but not measured. So a continuous random variable, this type of random variable, these are the variables can be measurable. So if the discrete random variable is countable, therefore a continuous random variable is measurable. These are the variables can be measurable. The examples of continuous random variables are, the first one is the amount of antibiotics in a vial. Second is lifetime of the light bulbs in minutes. Third is the length of wire rows. So these are the variables cannot be countable but can be measurable. Alright, so the next one is the probability distribution of the discrete random variables. So before we describe what is the probability distribution, so let me ask you two questions. The first question is, how can we determine the possible values of the random variables? So since this is our goal for this topic. And the second one is, how can we construct a probability distributions, particularly in a discrete random variable? So to answer with that, so let's define first what is a probability distribution. So when we say a probability distribution, it is a correspondent that assigns probabilities to the values of a random variables. A probability distribution is also called as the probability mass function. So if you counter the word the probability mass function, it pertains to the probability distribution. A probability distribution of the discrete random variables, it is a listing of possible values and corresponding probabilities of the discrete random variable, or a formula for the probabilities. So overall, when you say probability distribution, it consists of all possible values of the random variable and their corresponding probabilities. Okay? So next, a probability distribution can be represented by using a graph, table, or notation formula. You can present a probability distribution in three ways: the graph, table, or notation formula, or equation. So a probability distribution, it can be denoted by PR of x or the P of x in some references. It means that the probability of the random variable x. And the probability distribution has two properties that we need to satisfy to say that this illustration or this representation is a probability distribution. So what are the two properties? The two properties are, the first one is each probability of the random variables or each probability of the values of the random variable must be greater than or equal to 0 but less than or equal to positive 1. The second property is if the summation of the probabilities must be equal to positive 1. If the two condition or if the two properties are satisfied, therefore we can say that this graph, table, or notation formula, it represents as a probability distribution. So now let's answer the two questions earlier. The first question is on how to determine the possible values of the random variables. So to get or to determine the possible values of the random variables, so we have two steps on how to determine it. So these two steps are also included on how to construct a probability distribution of the discrete random variable. So what are the first step? The first step is you're going to list down the sample space of these experiments. So you're going to list down all the possible outcome of the experiment. So if you are throwing a die, so what are the possible outcomes that will come out on that experiment? So that would be number one step. And the number two step, we're going to count the number of random variable on each outcome and assign this number to this outcome. So if the random variables is talk about the number of heads, if you are tossing a coin, so you're going to count the number of heads in each outcome of these experiments. And then after that, we're going to observe what are the numerical values that appear on that experiment. So that would be the possible values of the random variable. So these two steps or these first two steps are the steps on how to determine the possible values of the random variables. And these are it is also the steps on how to construct a probability distributions. Okay, so to construct a probability distribution, we can follow the another two additional steps. So the two additional steps are, the number three is you're going to construct a frequency distribution of the values of the random variables. So in number three step, we're going to count the number of appearance or a number of occurrence on the given random variables. And lastly, you're going to construct the probability distribution of the random variable by getting the probability of occurrence of each value of the random variable. So you're going to determine the probabilities on each values of the random variable. So these are the four steps on how to construct a probability distribution of the discrete random variable. So for better understanding, so let us apply it in our given example. So in our given example, suppose two coins are tossed and we are interested to determine the number of heads that will come out, and let us use h to represent the number of heads that will come out. So our goal for this example is we're going to determine the values of the random variable h and construct a probability distribution. So the name of the experiment is a tossing of two coins, and the events of this experiment is you're going to determine the number of heads that will come up on this experiment. So the number of heads is our random variables, and which can be represented as using a random variable which is h. So h is a random variable which represents as the number of heads. So this is our goal for this examples. Is you're going to determine the values of the random variable h, which represent the number of heads, and we're going to construct a probability distribution of the random variables. So to construct with that, so let's proceed to the first step. On the first step, we're going to list down all the possible outcomes. So if you're tossing a two coins, so there are four possible outcomes. So the first one is the tail head, second is head tail, third is head, and then fourth is the two tails. So these are the possible outcomes if you are tossing two coins. So that would be the first step. Then next, the second step is you're going to count the number of random variables. So since our random variables pertains the number of heads, so therefore we're going to count the number of heads on each outcomes of the experiment. So on the first outcome, we have one head. The second outcome is also one head. And then the third outcome, we have two heads. And then fourth outcome, we have no number of heads. So if we observe the number or the numerical values of the possible outcomes of the random of the experiment, so the values of the random variables are 0, 1, and 2. So these are the possible values of the random variable h, which represent as the number of heads. Okay, so the values of the random variable h must be arranged it into lowest value into lowest value to highest value. Okay, so if someone asking you what are the possible values of the random variable h, so the answer will be is the possible values of the random variable h, which represent as the number of heads, are 0, 1, and 2. So there are three possible values. Next is the third step. We're going to construct a frequency distribution by determining the number of occurrence or the number of appearance of each values of the random variable. So let's start with the values of 0. So the frequency of the values of 0 is 1, because if as you can see in our second table or second column, so there are 1, 0 appear on the experiment, or 0 head appear on the experiment. Okay, next, the frequency of the values of 1 is 2, because in our experiment there are two number of occurrence or number of appearance on that particular value. And then last step, last value, which is 2, we have 1 frequency. If you get the total of frequency, we have 4 total frequencies. So as you can see in our total frequency, it the same with the number of possible outcomes. So if the possible outcomes is equivalent to 4, therefore it must be equal to 4 comes to the total frequency. The total possible outcomes is equal to the total frequencies. So if one of them are not equal, let's say for example, we have 4 possible outcomes and the total frequency is 3, so therefore there's something wrong with your experiment. So there are some lapses during your experiment. So you have to go back to your experiment and see what are the lapses or what are the lapses in your experiment for able to correct your frequencies. Okay, so for the last step is you're going to get the probability of each values of the random variable. So take note, people. So since we are using the h as our random variable, dapat throughout ng ating experiments is h po ang gagamitin natin for the random variable. Okay, so now let's move on to the first value. So the probability of having a 0 head is 1/4. So, paano ba natin siya nakuha? So, ang gagawin lang natin is you're going to divide the number of frequency of each values of the random variable. Let's say, for example, 0. 0 has 1 frequency. And then divided by 4, so therefore the answer will be 1/4. So, the probability in getting the 0 head in this experiment is 1/4. Okay, next. The probability of 1 or getting 1 head in the experiment is 2/4 or 1/2. Okay, so the 50% is the probability in getting the 1 head in this experiment. Okay, next, the probability in getting the 2 heads in this experiment is also 1/4, because the frequency of the values of 2 heads is 1, then divided by 4, that would be 1/4. Therefore the probability in getting the two heads in this experiment is 1 over 4. Okay, now to illustrate the probability distribution, we're going to take the third column, which is the values of the random variable h, and the fifth column, which is the probability of each values. So as we recall, the definition of the probability distribution, it describes as the possible values and their corresponding probabilities. So therefore, to be able to illustrate the probability distribution using a table, so uh, this is the illustration of the probability distribution. So we have the values of the random variable h and the probability and their corresponding probabilities. Okay, so we have 0, 1, and 2. For the probability, we have 1/4, 1/2, and 1/4, respectively. Alright, so let's move on to the next example. So a basket contains 10 ripe and 4 unripe bananas. If 3 bananas are taken from the basket, one after the other, determine the possible values of the random variable R, representing the number of ripe bananas. And we're going to construct a probability distribution. So in a basket, consists of 14 bananas. So 10 among them are ripe bananas and then 4 among them are unripe bananas. If we're going to choose 3 bananas, which taken from the basket, we're going to determine the possible values of the random variable R, which represent as the number of ripe bananas. So the random variable of these experiments is the random variable R, which represent the number of ripe bananas. So for the unripe bananas, we're going to use a variable which is U. So if you're going to choose 3 bananas taken from the basket, so what are the possible values? So let's move on to the first step. In the first step, we're going to list down all the possible outcomes. So the possible outcomes of these experiments are the 3 ripe bananas, 2 ripe bananas, and 1 ripe bananas, unripe bananas, 2 ripe bananas, ripe bananas, unripe, ripe, tatlong unripe bananas, URU, UUR, then RUU. So there are 8 possible outcomes of these experiments. Next, the number 2 step is we're going to count the number of random variables. So since our random variables pertains to the number of ripe bananas, which represents as R, a capital letter R, so therefore we're going to count the number of R on each outcome of this experiment. So on the first outcome, we have 3 ripe bananas. Second, we have 2 ripe bananas. Third is 2 ripe bananas. And fourth, we have also 2 ripe bananas. On the fifth outcome, we have 0 ripe bananas. And then 6 is we have 1 ripe bananas. 7, 1 ripe bananas. And lastly, we have 1 ripe bananas. So as we observe, the numerical outcome of this experiment, so therefore the values of the random variables are 0, 1, 2, and 3. So there are 4 possible outcomes or possible values of the random variables in this experiment. So we have 0, 1, 2, and 3. Next is the third step. We're going to count the number of frequency by not counting the number of occurrence, the number of appearance of each values of the random variable. So for the values of 0, we have 1 frequency. So as you can see in our second column, we have 1, 0 appear on the experiments. Next, for the values of 1, we have 3 frequency. For the values of 2, we have also 3 frequency. And lastly, for the values of 3, we have 1 frequency. So for the total frequency, we have 8 frequency as the number of possible outcomes of this experiment. Okay, next, for the last step is we're going to get the probability of each values of the random variable. So let's start with the values of 0. So the probability in getting the 0 ripe bananas is 1 over 8 because the frequency of the values of 0 is 1, then divided by the total frequency, which is 8, so therefore the probability is 1 over 8. Okay, so the probability of each values of the random variable can be expressed using a fraction form, a decimal form, or a percentage form. So in this case, we're going to use a fraction form to represent or to express our probabilities. Okay. Next is the probability of getting one ripe bananas in the experiment is 3 over 8. So the frequency of 1, or the values of 1 is 3 divided by the total frequency, which is 8. So therefore, the answer will be 3 over 8. So if we're going to use the fraction form as your probability, or to express the probability of this experiment, make sure that is in a lowest form. Okay, can be expressed in a lowest form. Next is for the decimal naman. If you're going to use a decimal form to express the probability, make sure you have to round off it into 2 decimal places. For the percentage, we're going to indicate the percentage symbol. Okay, next. For the values of 2, the probability in getting the 2 ripe bananas is also 3 over 8. So because the frequency of the values of 2 is 3, the total frequency is 8. 3 divided by 8, that is 3 over 8. Next is for the values of 3, the probability in getting the 3 ripe bananas is 1 over 8. Because the frequency of the values of 3 is 1, and then divided by the total frequency, that is 8, that the probability is 1 over 8. Okay? So the probability distribution of this experiment is, ayan, as you can see on the screen, on the first column, we have the values of the random variables, which represent as R in this experiment. So we have 0, 1, 2, and 3. On the second column, we have their corresponding probability. So 1 over 8, 3 over 8, 3 over 8, 1 over 8 respectively. So this is the illustration or the representation of the probability distribution using a table. Okay, so to say that the given table, or the probability, this table is a probability distribution, we need to satisfy the two condition, or the two properties. So on the first properties, we need to check if each probabilities must be greater than or equal to 0 but less than or equal to positive 1. So since our probabilities are greater than 0 but less than to 1, so therefore the first property is satisfied. Okay, next. On the second property, if we're going to add or going to get the summation of all probabilities on each values of the random variable must be equal to positive 1. So since if we're going to add 1 over 8, 3 over 8, 3 over 8 plus 1 over 8 is equal to 8 over 8 or 1, so therefore the second property is satisfied. So since the two properties are satisfied, so we can say that this table is a representation of the probability distribution, right? Okay, next. So consider the probability distribution of the number of ripe bananas given below. So this table below represent a probability distribution for the number of ripe bananas. So using this table, we're going to find number 1 is the probability in getting the R that is equal to positive 3. The second is the probability that the R is equal to 1. Number 3 is the probability that this R greater than 1. Fourth is the probability that the R is less than 2. And the fifth one is you're going to get the summation of the probability of the random variable R. So let's start with the number 1. So in our number 1, we're going to find the probability that the R is equal to 3. So for able to get the probability in getting the 3 ripe bananas, we're going to look our tables and see the values of 3 in this table. So in this table, the corresponding probability of the values of 3 is 1 over 8. So therefore, the probability of R is equal to 3 is 1 over 8. So that would be our final answer. Okay? So since we are using this equal sign, so therefore we're going to get the corresponding probability of the values of 3 on the number of ripe bananas. Next, the probability that the R is equal to 1. So our number 2 is we're going to determine the probability in getting the 1 ripe bananas. So R is equal to 1. So katulad ng ating number 1 given, we're going to look the number 1 value in our table, and then let's see what is the corresponding probability. So the corresponding probability of the values of 1 is 3 over 8. So therefore, the answer number 2 is 3 over 8. So that would be our final answer. Next is we're going to find the probability that the R that is greater than 1. So how we're going to get the probability in this given. So take a look at our values of the random variables. So what are the values that is greater than 1? So the values that is greater than 1 is 2 and 3. So therefore, class, we're able to find the probability that the R is greater than 1. Therefore, going to add the probability of 2 plus the probability of 3. So the probability of 2 ripe bananas is 3 over 8 plus the probability of 3 ripe bananas is 1 over 8. So if we add two probabilities, therefore the answer will be is 4 over 8 or 1 half. So the probability in getting the more than 1 ripe bananas is 1 over 2. That would be our final answer. Okay, next. Next is you're going to find the probability that the R that is less than positive 2. So katulad lang din ng number 3 problem natin, o number 3 given natin, we're going to find what are the possible values that is less than, what are the given possible values that is less than positive 2. So the values that is less than positive 2 is 1 and 0. So to determine the probability that the R is less than 2, we're going to add the probability of 1 plus the probability of 0. So the probability of 1 is 3 over 8, as we can see in our table, plus the probability of 0, which is 1 over 8. So if we add two probabilities, therefore, the probability of the R that is less than 2 is 4 over 8 or 1 over 2. So that would be our final answer. Okay, for the last given, so we have the summation of the PR of X. So we're going to get the summation of the total of the probabilities of the random variable R. So to get the summation, we're going to add the probability of 3 plus the probability of 2 plus the probability of 1 plus the probability of 0. So the probability of 3 is 1 over 8. For the 2 naman is 3 over 8. Probability of 1 is 3 over 8 plus the probability of 0, which is 1 over 8. That is equal to 8 over 8 or positive 1. So therefore, the summation of the probabilities is positive 1, or 8 over 8 or positive 1. Finding the discrete probability distribution described by a formula. So a probability distribution can be described by using a notation formula or an equation. So how can you say that the given notation formula or an equation represent as a probability distribution? So let us use the given. So determine whether or not the formula below describes a probability distribution. So the P of x is equal to x plus 1 over 7 is an example of notation formula or an equation. So using this given, we're going to prove whether this equation or notation formula is an example of probability distribution, or can be represented as a probability distributions where x is equal to 0, 1, and 3. So the variable x here is the random variable of this experiment. So if the given notation formula represent as a probability distribution, therefore we're going to find the following three given. So number 1 is we're going to get the probability of x that is equal to positive 3. Number 2, you're going to find the probability of x that is greater than or equal to positive 1. And the third one is you're going to find the probability of x that is less than or equal to positive 1. Okay, so before we find the three given probabilities, so we're going to prove first if the given notation formula can be represented as the probability distribution. So to prove our notation formula as a probability distribution, we need to satisfy the two conditions or the two properties. So to satisfy the two properties, we need to find first the probabilities of each values of the random variable x. So by substituting the given values of x to our equations. So let's start with the value of 0. So if we're going to substitute 0 in our equations, we have 0 plus 1 over 7 is equal to 1 over 7. Ibig sabihin, the probability getting the 0 that is equal to 0, or the probability in getting the x is equal to 0 is 1 over 7. Next is going to substitute the positive 1 or the value of 1 in our equation. So we have 1 plus 1 over 7 is equal to 2 over 7. Next is going to substitute the value of 3. So we have 3 plus 1 over 7 is equal to 4 over 7. So these are the probabilities of each values of the random variable x. So let's illustrate it in our table. Yeah. So the first column we have 0, 1, and 3 as the values of the random variable. In the second column, we have the probabilities of each values of the random variables. We have 1 over 7, 2 over 7, and 4 over 7 respectively. Now let's prove if these probabilities can be satisfied to our properties. So the first properties, as you can see, the 1 over 7, 2 over 7, 4 over 7 are greater than 0 but less than equal to positive. Greater than 0 but less than positive 1. So we have one check for the first property, or the first property is satisfied. The second property, if we add this probabilities, we have 1 over 7 plus 2 over 7 plus 4 over 7. We have 7 over 7 or 1. So therefore, we have checked for the number 2 properties. The summation of the probabilities must be equal to positive 1. So since the two properties are satisfied, therefore we can say that the given notation formula can be represented as probability distribution. So if since the notation formula represent as a probability distribution, we can find the three given probabilities. So let's start with the number 1. So what is the probability that the x is equal to positive 3? So to get the probability of this given, we're going to look our table and see what is the corresponding probability of the values of 3. So since the value of 3 correspond to 4 over 7, therefore the probability of x is equal to 3 is 4 over 7. So next, the probability that this x is greater than or equal to positive 1. So to get the probability of this given, we're going to look for the probability that is greater than or equal to positive 1. So the values that is greater or equal to 1 is 1 and 3. Since we are using the greater than or equal symbols, therefore we can include the positive 1 and the positive 3 as our values. So to get the probability in this given, we're going to add the probability of 1 plus the probability of 3, which is 2 over 7 plus 4 over 7 is equal to 6 over 7. So the probability in getting the at least 1 is 6 over 7, or the probability of x that is greater than or equal to positive 1 is 6 over 7. So lastly, we're going to find the probability of x that is less than or equal to 1. So to get the probability of the given, we're going to look for the probabilities that is less than or equal to positive 1. So these are the 0 and also 1. So since we are using the less than or equal symbol, therefore we can include the positive 1 as the included value. Okay, so to get this probability, we're going to add the probability of 1 plus the probability of 0. That is 2 over 7 plus 1 over 7 is equal to 3 over 7. So the probability in getting the x that is less than or equal to positive 1, or what is the probability of x at most 1 is 3 over 7. Next, graphical presentation of the discrete probability distribution. So a probability distribution can be represented by using a graph. So this graph, we called it as a probability histogram. Okay, so what is a probability histogram? So yung probability histogram natin, or the word histogram, is the same, almost the same with a bar graph. So the difference is, kung sa ating bar graph, yung ating bar doon ay magkakahiwalay or merong patlang sa mga bars natin. Sa histogram po natin, para din siyang bar graph, kaso nga lang yung mga bars doon ay magkakadikit-dikit. Okay, so to illustrate with the probability histogram, let us have an example. So suppose we have the given probability distribution for the number of ripe bananas, and we're going to illustrate it using a graphical representation, which is the probability histogram. So construct the probability histogram of the probability distribution of the number of ripe bananas given below. So to illustrate that, so let's draw a vertical line which is represented as the y-axis, and the horizontal line which represent as the x-axis. So in our, as you can see in our slides, so this is an example of probability histogram. So a probability histogram is a bar graph wherein yung mga bars natin ay magkakadikit-dikit. So kung i-analyze natin yung ating probability histogram, sa vertical axis natin, nakalagay po doon yung ating probabilities. And then on the horizontal axis, nakalagay naman po doon yung mga values of the random variable. So if we're going to illustrate this table or this probability distribution using a probability histogram, so this is our illustration, or this is our graph of our probability distribution. So we're going to use a probability histogram or the histogram to represent the probability distribution or the graph of the probability distributions. Okay, so next, construct the probability histogram of the probability distribution of the number of heads given below. So the given below, or the given table below, is the probability distribution for the number of heads. So using this table or using this data, we're going to illustrate it in our probability histogram. So as I said earlier, so to illustrate the probability histogram, we're going to draw a vertical line which represent our vertical axis, and then horizontal line which represent our x-axis. On the vertical axis or the y-axis ay nakalagay po doon or naka-indicate po doon yung ating probabilities, and for the horizontal line natin, horizontal axis natin, naka-indicate po doon yung ating values of the random variable h. So as you can see, this is an example, or also example of probability histogram, particularly for the number of heads. So this is the end of our session for this morning, for this session. I hope ay natututo yung lahat. Okay, for those who have questions, you can message me in a messenger for able to address your concern or questions. So thank you very much and have a good day, everyone.